Good day and welcome to another Micrographics webinar. We are an Autodesk partner and reseller. My name is Sean Bauer and I will be presenting this webinar today on 5 December 2025. I am an applications engineer and an Autodesk AEC technical consultant with Micrographics, and today's topic is AI-powered design and sustainability in the AEC collection. If you find this webinar to be informative, please like this video and subscribe to our channel for future webinars. Right, so let's get into it. Okay, so what we have on the agenda for today, we'll have an introduction. In the introduction, I will go through introduction of the different software packages that I was looking at with regards to the AEC collection, thinking of the sustainability and how AI can enhance our workflows. Then we'll look at the generative and AI driven design in Revit and AutoCAD, sustainable master planning with Autodesk Forma from concept to early stage planning, and then connecting the early ideas. And then the demonstration part, I will show demonstrations throughout the webinar with each topic, and then we will have a conclusion. So, hi everyone and welcome to this webinar. The AI-powered design and sustainability in AEC collection. The design and construction industry is evolving faster than ever. We've moved from using software purely for automation to leveraging artificial intelligence for intelligent design, helping us make smarter, faster, and more informed decisions. At the same time, sustainability has become a central responsibility in every project. It is no longer optional, it is expected of us. We have our regulations, our SANs, our NBR, our NHBRC, international standards organizations. We have a lot of mandates and regulations that we have to comply to when we submit our plans. Our designs must perform efficiently. They must respect the environment and contribute to a better built world. And that's where the AEC collection shines. It brings together intelligent tools like Revit, AutoCAD, Forma, Civil 3D, InfraWorks, Navisworks, and more, all also on the Autodesk Construction Cloud. It is all designed to connect workflows, connect data and decisions, enabling teams to innovate sustainably. Today, we'll explore how AI and sustainability converge inside this ecosystem and how they empower us to design with purpose and precision. Looking at sustainability, we have our regulations and our client demands for low carbon footprints, for energy efficiency, and for resilient designs and more. And with speed, we have tight deadlines, rapid iteration cycles, and fast-track construction increase the pressure to deliver faster. Then we have team alignment. For multidisciplinary teams, they often work across different time zones and platforms, creating silos and risks. So how do we fix that? As stated by the World Green Building Council, over 40% of global carbon emissions come from buildings and construction. So in this webinar, I'll show a few examples of how I would suggest one would go about the building life cycle. Where do you start? Where do you go next? And where do you end? As an example workflow, you could start in Forma for your site analysis. Understanding your site and the immediate environment surrounding your structure is vital, and it's really important for you to know, where is my site? What is it like? What are the conditions there like? The wind pressure, the temperatures, the amount of sun hours, the amount of exposure your building has to the elements and the environment. You can send that site analysis and the information, the data, to Revit with the built-in add-on that you can send data to Revit within Forma. Revit can then export that entire 3D topography with the buildings, with all the data, to DWG format to use in Civil 3D and AutoCAD, including the specialized toolset for AutoCAD for further development. For example, the site can be accurately detailed with roads and infrastructure, contour elevations, your northings, your eastings, all of those things can be done and prepared before you start with your structure. Link the Civil 3D and AutoCAD within Revit. You can insert links and manage them, keep them real-time updated. And then with the active real-time update, you also have the feedback and the collaboration, which can be used for clash detection and more. And then on the ACC, you will have the Autodesk Construction Cloud, you will have your centralized repository. So in Revit, you can do then the BIM model, the construction documentation, the interference checks and more. And then using ACC BIM Collaborate Pro or Navisworks, do your clash detection between the disciplines. There are also additional add-ons, plugins, extensions, or even the default Revit renderings or Twinmotion, which is now inside Revit on the View tab. And you can do some visualization from pre-conceptual to sketch plans or even final renders for presentation. So here on the right hand side on this introduction screen, I showed a life cycle structure using ACC, your docs and the Construction Cloud as the centralized repository. All the other disciplines and software packages can work together in a life cycle continuously on the same drawing at the same time, making sure everybody works on the latest update of the same project and everybody's updated at all times. So as a suggestion, depending on your project needs and the scope of your project, my suggestion is to start in Forma with your site analysis. Depending on what your needs are, right? So you can do environmental analysis to understand your site, the best orientation for your structure, determine the parameters for your building, taking into account your local authority mandates and regulations and all the other factors such as the prominent wind direction, your sun hour exposure on the facades, where you have the best solar exposure for solar power generation, where do you put your solar panels, microclimate conditions, what the temperatures are like throughout the year, your operational energy usage that will be required to run this building, the noise analysis surrounding your structure, are there train tracks close by, are there highways, what are the noise conditions, so you can prepare for that, determining what kind of insulation you would require, what thickness glass you need to require, and more for the best orientation and placement of your structure on the site. So why do we need smarter architecture today? Because the demands on architects, engineers, and project teams have never been higher. First, sustainability is no longer optional. It's a mandate. We have our SANS 10400X as an example. Whether you are targeting net zero buildings or simply complying with new energy codes, we must reduce our carbon footprint to some extent. Second, there is speed. Projects are moving faster. We need to design, analyze, iterate, and deliver in weeks, not months. And third, we have team alignment. With teams spread across offices, disciplines, and time zones, we must overcome the disconnection. Tools that unify the workflows and provide a single source of truth are critical to avoiding rework, clashes, and delays in construction. Here's an example of the different types of analyses that one would be able to do. This is what it looks like within Forma. You're able to compare different proposals as well if you decide to make a change to the building, to change the orientation, the placement of the building. What would the different factors be like on your site? Top left, you see there it is the temperature, then you have the source, the score, then the second one, which shows how much, what type of glass one would have to place, what's the best use, what type of glass, and then you have the solar power, how much kilowatt hour per square meter you could generate if you placed solar panels on the roof, for example. Then you have your area metrics at the bottom left. Then you have your sun hours and bottom middle per day. So you select the day and month of the year, and you can see how much sun exposure you get. And then your wind pressures, a meter per second. Okay, so this is how I would suggest one would do it. You would go into your Autodesk account. If you have the AEC collection, you would go look for Forma, and you can access Forma through your Autodesk account. I have saved my Forma as a favorite on my favorites tab. You have your hubs, your projects, and your regions which you are part of. So you either get invited to a project or you create your own new sites, demo sites, new projects. And then you have your recent used projects, all connected through your Autodesk Construction Cloud Docs hub. You can create multiple proposals and as many as you require. Design the different types of buildings that you need. If you want Forma's default line building, basic buildings, you can, or you can sketch your own in 3D. So there'd be examples of the different types. I've placed all the different types of buildings here just to show the examples of what you could do. Within your buildings, you can also, before you even start with your Revit detailing of your structure, you can draw your own layouts. Get an idea of what, where you're heading. You can place multiple different iterations of floor plan types, window placements for the best orientation, best sunlight, those kind of things. And then it models it for you in 3D. Once you send this to Revit, those lines that I drew become walls, actual components, 3D components in Revit. You can swap them out for the different type of wall. And here's the example. I'm taking my proposal 1 and proposal 2, two different designs, and I am comparing the one versus the other, one to the left and one to the right, to see what the factors, how they were updated when I made a change to my building. You're able to right click and split the screen to add more analyses to compare and view. There's your solar energy, how much you could generate. Selecting just that building, how much energy can you generate on average. On the left we have our wind. There's an inspect tool, so you can place spot inspections to see what the wind conditions would be like surrounding your building, on your building. And this is all pre-conceptual stage, right? There's no design yet. It's just an idea of understanding the site first. Then we have our sun hours. So on the September 10th, you have 9.5 hours of sunlight on that roof. The temperatures will be roughly 27 degrees. This is based on your local weathering data systems. So this is done in Melkbosstrand on the Western Cape coastline, South Africa. Okay, so daylight potential is based on roofs and facades to see what it's like. So at the bottom there's a score that shows you conventional windows designs should be satisfactory. So single clear glazing should be satisfactory there. No need for double glazing in the type of temperatures that you receive there. It doesn't go into the minuses with snow and those kind of things. And going back to the site design. With the drop down there's the add-on. You can download it there and then send it to Revit. On the right hand side is where you select which type of analysis you would like to do. There are also additional extensions that you can download for free. A lot of them are for free. That's an example of the parking metric test fit. Designs parking spaces for you using AI. There are some of the ones that I've already added. And then if you click on the add extensions, you can go look for other ones that are available. These are just the defaults that are here. You can go and to the Autodesk App Store online and go look for more. ArcGIS information, generate 3D building design options with the most advanced 3D generative AI, ArchiStar. So it generates the buildings for you with your inputs. You say 3-story building, office block, that's kind of prompt. And then there's Veras, which is a brilliant AI visualization tool for short videos and still images, which I will show you during this webinar. So let's send this to Revit, and then I can show you what it looks like once you've loaded it into Revit. That's the end result. That is where you would find it on the Massing and Site tab. Once you've added that plugin, you can load the proposal into Revit from Forma. Also, you can update the proposal, and you can also unlink it once you're done with your analyses. What is quite brilliant is it brings in contours and everything already. So before you have your site surveyor sending you data for contextual information like the contours, how the site falls, what the conditions are like, at least you have a really good starting point, right? So at this point, it would bring in roads and buildings, existing buildings and roads, by their name in groups. So you can decide which ones you want to keep, which are relevant, and then you can remove the ones that you don't want. And then what I did is one small example there on the right hand side next to the house on the far right. I made the roads that I brought in an actual path, an actual road in Revit. So I converted it using the pick line tool. So you can then model the street and the landscape inside Revit. With that, then you can send it to DWG format. So you can use it in AutoCAD, Civil 3D, or other software packages for further development. Cleaning out the contours, making it look nice and neat. You have control over the layers, assigning the layers to them. And then that's what happens. In AutoCAD, this is an AutoCAD example, and use Civil 3D for this example. Place your geolocation, go search for your address, where the building is. You have different sort of map views that you can select. You want street maps or satellite imagery. Edit your location to be exact. Make sure you are selecting the right place. Select the correct coordinate system. I used the Hartebeeshoek coordinate system. And then with this, you have a really good start without having to have multiple consultants working on the same thing. I did this all by myself. So the idea is that you can start with a very nice base point, having the right site data, understanding what the winds are like, the sun exposures are like, all the environmental conditions, and you're ready to kickstart your sketch plan phase or design phase. And then once you've made your changes in AutoCAD, you've updated the layers, cleaned it out a bit, just cropped the area that you require. You might not need the entire Malpostrand as an example in this project. You don't need the entire city. You just need your block or just your earth. Then you can go and crop it out. When you reach this point, one would want to start creating a centralized model, right? You want to save it on the construction cloud. You have the choice within your network or in the cloud. I'm doing within the cloud so that we can connect with multiple users from multiple different disciplines and software packages collaboratively wherever they are sitting, whether they're on the same time zone, same continent or not. We can all work together on the same project at the same time. Okay, select your hub and the project. This is my Autodesk Construction Cloud Docs Forma example project. So I'm just creating a central model, centralized cloud work shared co-author model. So multiple people can work on the same model at the same time. Right. With that, we have a cloud model. We can go create worksets now. You can do this before the time or after the fact. And you can add a few worksets. Give every discipline or team member or by category. It's up to you how you define your worksets. I prefer doing it by discipline. So every discipline has their own model to work on or their own workset to do their part. So architectural, structure, mechanical, electrical, civil, infrastructure, and interior. This, I will do the architectural part. And there we have our base model. Now what one would do is each discipline would have their own model. All of them can be linked into the main model where maybe the topography lives. Or you can use the architectural model as the main model depending on your circumstances and your scope and project needs. And then each person can go and within their own worksets and their own models start collaborating. So here's my architectural model. I further defined what I did with my conceptual mass that came from Forma, and I converted those walls and those elements into actual Revit geometry. And here you have an example of your building. So instead of it just being a shell, we have all the internal elements as well. Then you can do a nice draft render in Revit using the Revit renderer, or you can do cloud rendering as well if you need be, or Twinmotion. It's an option. It's now available within your AEC collection. Then you have additional ones, V-Ray, Lumion, D5 Render, Enscape, and so on. But for this exercise, I'll be using Veras, which is from the Chaos Group and Evolve Lab. It's an AI tool that does all the settings for you for the rendering. So you basically select an image that looks like the way you want it to look, and you click render. That's about it. So it's a very, very easy, quick tool for pre-conceptual design things. If you're on the Compose tab, you do have the option to do a prompt, the way you would Google search or talk to ChatGPT. You just type in a prompt, what you want, and a negative prompt just saying what you don't want changed. So I'd said keep my original building. You can add more geometry if you ask it to add more things, and you can just specify it in the prompt. Here are some examples. These renders just take a few seconds. They're usually between 5 or 10 seconds to do, and it gives you a really nice idea of where you're heading. And all of this started with just a conceptual mass in Forma. So within one day, you have already something to present to the client saying, this is where we're heading. Are you happy with it? Is this the look you're going for? But more than that, you understand contextually what the site is like, right? The environment. What is the sun and the wind and the microclimate in your specific area? Geolocated data based on actual weathering data systems. And this is all run with AI. So it's quite brilliant how quickly one can get to a conceptual stage, which used to take much longer. We would go to site, right, and do a lot of calculations and things there on site. All right, then next, once you've reached this point, you would have all your different formats and files linked. Your Revit files for the different disciplines, or your DWG files for multidisciplinary coordination. Now it's time to develop your BIM project in Revit with construction documentation, doing interference checks and aligning the different disciplines with a cloud model to keep everything coordinated. So once detailed construction documentation, all disciplines are complete and ready for construction, then one would use that visualization tool to generate more accurate representations of your building. With Veras, you can do still renders, panoramas, and videos, and it takes seconds with Generative AI. So looking at this construction documentation slide, these are the different types of detailing views that are available within Revit. You get floor plan views, ceiling plan views, elevations, sections, callouts, drafting views, detail views, and 3D detail views. And for floor plans, those are horizontal cut views through the building. The level of detail generally is from coarse to fine, depending on what you're trying to show. The use cases would be general layouts, floor assemblies, finishes, and fire ratings. Ceiling plans is a view from above, or looking up towards the ceiling. You decide which way you would like to look. If it's usually from medium to fine level of detail. It's for MEP coordination, ceiling finishes, and lighting layouts. Then your elevations, your projection views from the different sides. You can also do internal elevations or framing elevations. Then you have your sections, cut through slices of the building. You have wall sections, stair sections, foundation, detail sections, multiple different types of sections. Then you have callouts. Those are zoomed in details of larger views. So within your section view or within your elevation view, you would do a callout view to detail a specific connection, maybe the eave of the roof or foundation detail, those kind of callouts. Then you have drafting views. Those are independent 2D detailed drawings. They are not connected to your model itself, the 3D geometry. It's basically AutoCAD in Revit. So you have the line tools, and you can draw lines with different line types and line styles and line colors. Then you have detail views, which are enlarged detail-rich callouts. So you swap out the callout to become a detail view, where you would then start adding insulation and additional things, which I'll show on the next slide what it looks like. And then 3D views for isometric or perspective views from coarse to fine. Okay, so here are 3 examples of the different types of views when I referred to the drafting detail view and callout view. So the functions and tools for detailing Revit. While views are important, the real power lies in the detailing tools that Revit provides. So what you actually have to place them. We have detail components, line work tools, which are the same as the draw and modify tools within AutoCAD, filled regions similar to the hatch patterns in AutoCAD, detail lines, tags and annotations, keynotes and keynote legends, detailed groups, drafting views, and then view templates and filters, and detailing in 3D. So to the left there, you would have just that would be the detail view. So it's a drafting view. So it's not connected to the actual building. You would draw all of those elements using repeated components or in-place components that you would draw in 2D. Then you have the middle one, which is a call-out view. You would go and zoom in on a space, crop it out, and use the 3D geometry and then place 2D elements on top of it to resemble, like for example, the rebar and the connection. Add your multi-leaders, your specifications, your annotations, dimensions, and so forth. And then you also have the ability to do text and multi-leaders in 3D. So you can go do a section box, save your 3D view as a different view name. For example, this could be the 3D staircase, multi-story staircase, and then you can place text, which is nice to see on site for the contractors, what it must be like in 3D. Okay, so the introduction workflow is then ACC plus Revit plus CAD. That's the life cycle. Forma can be accessed through your Autodesk Construction Cloud Docs account. Members can be invited, and the project can be shared between all relevant members. Forma is an online application and no installation is required. The minimum requirement is access to the AEC collection and an invitation to the project, whether you're creating a project yourself or being invited to a project. Using ACC with Forma, Revit, AutoCAD Civil 3D, Navisworks, and the other AEC collection software to collaborate effectively. It's about aligning your designs, right? So within Revit, instead of using your open model or new model, you would then use your Autodesk projects to the far left of the screen, and that is where all your cloud worksheet models would live. For everybody to gain access, whenever they open it there, then they will create a local copy of the central cloud worksheet model. Okay. AI-powered design in Autodesk Forma, so the generative and AI design driven. So in addition to its intelligent analysis tools, Autodesk Forma now includes an incredible AI-powered rendering feature, which I showed briefly now within Revit. It is also available in Forma. So both of them, the use is the same. The new capability uses AI to generate photorealistic renders directly within the Forma environment, instantly transforming simple massing or conceptual models into realistic scenes, complete with materials, lighting, and context. What makes it so powerful is how it integrates seamlessly with Forma's real-time environment analysis tools. As you adjust the building's form or the orientation or the materials, you can see not only how the performance changes, but also how it will look in the real world. By combining performance data and visual intelligence, Forma allows designers to communicate ideas more clearly, gain the stakeholders' buy-in earlier, and maintain sustainability as a central focus before a single line is drawn in Revit or AutoCAD. And because everything connects smoothly into Revit, the AI-generated design intelligence carries through to the entire BIM process. So the additional tools that one could consider are mentioned here at the last point. Finch 3D, Veras, TestFit, One-Click LCA, Generative Design in Revit and Forma, Shadow Studies, Archistar, to name but a few, as you see on the image. on the slide there on the right hand side. Finch can generate layouts with multiple iterations for internal spaces, wall placements, door placement, window placement, furniture and other objects, elements or components from all disciplines. Depending on your input values, you set the rules. TestFit is used for automatic parking areas, whether you're inside of a structure, basement, outside exposed areas, shopping center parking lots, etc. Then the shadow study allows you to visually see the shadows of surrounding buildings interact with your structure and vice versa, which helps with layout and design changes, ensuring enough sunlight reaches the areas where you need sun. So in one-click LCA generative design checks compliance of your local mandates. You input the values and information, and the AI then can suggest better layout options for you, or it alerts you to that there are compliance conflicts. So here's an example of Vera's inside Forma. If you run Vera's there, you can also try the trial out if you just want to see how it looks. So to the left are my buildings that I didn't draw a single one of them. I used AI to generate all of the buildings for me to the left. Some of them are existing buildings of the actual area that I selected on the map. And then some of them are generated by input of the AI. I think it's called ArchiStar. It generates it for you. So as I mentioned in the previous slide, this is just an example of Veras from the Chaos Group and Evolve Lab, which generates fast renders. It literally takes seconds. Possible scenarios based on your prompts and input. So I asked for one based in the fall, so it would use this sort of color scheme. So then you can input multiple different prompts. You can do multiple renders at once as well. You can do 4 at a time. And then with this, you can share it with your clients, shareholders, stakeholders, owners, or other members of the team to show in which direction you are moving with this project. What is your idea? What is the preconceptual idea that you're heading towards? So this is at the preconceptual design stage before any lines have been drawn in AutoCAD or Revit, to get all members excited and have the right path set out for where the project is heading and get the buy-in from the persons involved with the project. Collaboratively connected through the Autodesk Construction Cloud using the Autodesk Free Viewer. For those members who do not have Autodesk subscriptions, it is a free online viewer called the Autodesk Viewer, which is accessed via the web browser. So you can do it on a cell phone, on a tablet, or any device which has access to the internet with a web browser installed. And then they can view it in 2D, 3D, and your clients can see what this building, what you're suggesting. This is sort of the idea that you're heading towards. Okay, so in addition to its intelligent analysis tools, Forma then also includes these additional features that one can use. And once this is done, send this to Revit and then start your design once you have the buy-in from all the right people. Okay, so meaning your preconceptual ideas, they have been presented, they have been discussed, and you have the go-ahead to start the design phase. With all these AI tools, which assist your design with speed, compliance, mandates, regulations from local authorities, layout suggestions, and more, you can send it then to Revit. Make your changes in Revit, use phasing and design options within Revit. Those changes can be sent back to Forma for reanalysis. See if the changes you made are now better suited for the site you are working on, the wind conditions, sun hours, solar exposure, and so on. Proposals can be reloaded in Revit in the Massing and Site tab. So you update the proposal from Forma in Revit. And then your Revit model, it cannot be sent from Revit to Forma. You have to export it as an OBJ format to reload it into Forma, but you can reload it into the same proposal. So you delete the massing structure in Forma and then replace it with the OBJ format that you've imported. And then rerun the analysis. See if those design changes helped, made it easier. Then more generative and AI design driven options. So previously I did discuss the Finch. There's just an explanation to see, you can read the description there and how it makes your life much easier. What's nice about Finch is that you can load previously used layouts. So let's say you did do a 2-bedroom unit or a 3-bedroom house at some point. Go take those layouts and save them on Finch. and then you can just swap them out quickly with your own designs, your own design style. You don't have to use the design style that the AI suggests. You can stick to your own concepts and your own design. And then within Revit, you once again have those multiple options. So Finch is just one of them. Whether you prefer using the default AI-powered generative AI tools, which are installed with your default Revit installation, it is called Generative Revit Generative Design. It's always there. It's in the ribbon. You can create case studies. You can also use it with Dynamo to do layouts for you, or you can use things like Finch to do the same thing or similar thing. If you do not like the Finch, there's a free trial that you can try out. If you do not like the Finch one, you can go search for different AI tools if you are considering giving it a go to speed up your own workflow. On the Autodesk App Store, which you can search for on Google, you can just type in the word AI for Revit or machine learning for Revit, and it will populate a few options for you. So in this webinar, I am simply showing you the possibilities and making suggestions. The idea is to assist your workflow to speed up the boring parts, setting out of your topography. Isn't it great that you can simply load the earth into Revit? You set the area, the city, the street name, and you have the contours, and you have information to start off with. And then at least you can get started whilst you wait for the civil engineers or the site surveyors to complete their drawings. Then you have a base to start with. So you can use Finch to generate a few layouts options for you, build a nice library within Finch for future projects, use your old projects. You can load your own previously used layouts into Finch, and then it's a simple click and play, and then you swap them out one for the next. Okay, so then AI-driven design in Revit. So Revit, where AI isn't just a background process anymore, it's part of the creative workflow. You could use then the generative design or adaptive components. Revit empowers designers to explore multiple solutions automatically, whether optimizing a floor plan for daylight, minimizing energy use, or balancing aesthetics with performance. Instead of manually testing design variation, the AI can evaluate it for you, providing instant feedback based on a predefined goal that you set, such as the cost, the energy use, the spatial efficiency. You decide how much space you require to walk around the island, for example, and it will remember those constraints, saying it must always be 900 millimeters space between different elements, and it will keep it like that. And this is just an example. So this would be a default shaded view in Revit using the Revit camera. Then using the Revit renderer, I placed some objects and I just did a draft render. And then you can take this draft render, send it to Veras just to make it a bit more attractive, more realistic in the sense of lighting and reflection. And then what's pretty decent is that you can go and create a nice video that you send to your clients. And this took about 12 seconds to create a short 5-second video. It's quite decent. And this is all based on that. Just this. This is the part that I did. The rest was given to me by AI rendering. Then other AI-driven design options that you have within Revit. So if you look there on the right-hand side on the screen, you'll see you can input a prompt. So you can talk to Revit and ask it to draw for you. So instead of you selecting the wall and the floor and the ceiling and the lighting and the elements, you type in the prompt. It's called Pele AI. It's an AI-powered assistant designed to revolutionize the way you work in Revit. So it doesn't automatically generate something for you. You have to give the prompts. So you're speaking to the computer saying, draw a floor, this is the area square meterage, or 7 meters by 5 meters, it's a concrete 170 slab. You have to specify what you want. The idea is to keep it simple though, one sentence at a time. You can go download it and try it out. There's the description of Pele AI. It's on the Autodesk App Store. Using cutting-edge artificial intelligence, Pele enables you to interact intuitively with Revit. Simply write or describe your task, and Pele will try to understand your needs and execute the work seamlessly. Whether it's generating the views, creating dimensions, organizing elements, graphic overrides, view templates, or running custom commands, Pele reduces the hassle of complex, tedious operations. An example would be generate a window schedule for me. Instead of you selecting all the fields and all the filters and those things, type it in as a prompt. Generate window schedule. Enter. So the idea is for AI-powered automation. Just write your request and Pele will attempt to automate it. Time-saving efficiency. It automates repetitive tasks, such as which saves you valuable hours. It has seamless integration. It's on the ribbon, and you just simply type the prompt. And then enhanced productivity. It focuses on creative and high-value tasks. While you focus on the creative part and the high-value things, and then Pele can handle the mundane rest. And then consistent performance. Ensure handling of detailed requests with reliable and predictable outputs. So this AI extension works with prompts that you insert one sentence at a time to model your building. The idea is to reduce the time spent on repetitive things like tagging or scheduling or a repeating detail. You've already done one foundation detail. Ask it to copy and duplicate it on the other foundation points. Create levels for you, or set out the building's framework, or maybe the site boundaries. The tasks that do not require an architect or engineer's creativity and methodologies. The idea is not for AI to take over and do your job. You're still the one writing and inputting the prompt. You're still the one telling Pele what you want and how you want it. If you want to create a window schedule, type it in, create window schedule. The idea is to generate a base which you can then populate and use and make it neat in the way you want it with the right formatting and fonts and style. So create a conceptual space to kickstart your design process, set up the levels. These tasks take time, and it's not your creativity that is being utilized. It is a lot of clicking to create 12 levels, each with its own level name, offsets between each level. So why not just simply type it out and let Pele do the work and create it for you. So once your project is nicely set out, generate a few floor plans using one of the other AI tools, and then you can start working. Then you have all the base things laid out for you. Okay, looking further now, including Revit and AutoCAD. The Autodesk AI announcement that they made was Autodesk introduced Autodesk AI, a technology designed to enhance creativity, solve problems, and eliminate non-productive work across various industries. Capabilities would include Autodesk AI provides intelligent assistance and generative capabilities, allowing users to explore and produce innovative results efficiently. Industry applications, architecture, engineering, construction, and operations. Tools like Autodesk Forma and Construction IQ use AI for planning, design decisions, and risk management. Product design and manufacturing. AI capabilities in Autodesk Fusion and Blank AI help in conceptual design exploration and automated manufacturing processes. Media and entertainment. AI is already in Autodesk Flow and Maya. It automates scheduling and creative tasks, enhancing productivity and creativity. The future outlook. So Autodesk plans to continue investing in AI with a focus on security and ethical practices. To drive better outcomes for businesses and the world, Autodesk is integrating AI into AutoCAD and Revit through several innovative tools. AutoCAD specifically, My Insights, already available on your home page. It provides personalized recommendations and tips based on user behavior to improve productivity. It gives you a drawing history that uses AI to compare past versions of drawings, helping users track changes and understand design evolution. Then we have the new smart blocks to suggest the most relevant blocks used based on usage patterns, saving time in repetitive tasks. And then within Revit, we also have the Autodesk Insights and Generative Design, which we discussed earlier. Then you have the additional add-ins, like I've shown throughout this webinar, like Forma and Veras and so forth. These tools aim to enhance efficiency and decision making in the design process, not to take over the job of the architect or engineer. Okay, looking at AutoCAD specifically. Okay, so let's look how AutoCAD integrates artificial intelligence directly into the design process. The latest Smart Blocks feature can search, detect, and convert repeated geometry into reusable blocks automatically, helping you clean up drawings and improve consistency in seconds. AutoCAD's AI doesn't stop there. It assists with automatic placement suggestions, recognizing patterns in how you build your designs and proposing the next logical step. These intelligent tools dramatically boost drafting efficiency, allowing designers to spend less time on repetitive editing, placing columns, orientating your doors, the door swing opening, and more time on innovation and problem solving. It's combined with built-in collaboration tools. So AI in AutoCAD streamlines both documentation and coordination, keeping every team clean, accurate, and ready for BIM integration. So connecting through the Autodesk Construction Cloud, keeping everybody updated. So the future of drafting with automation and AI. The Smart Blocks has the search, place, and convert, the object detection and detect PDFs to convert PDF data into blocks, usable AutoCAD lines. So it's an AI-assisted object recognition that can convert the detected items on a PDF that you've imported with vector data into blocks. Then there's the Autodesk Assistant, contextual assistant that has suggested actions and learning resources, and then the AI-assisted recommendations in the AutoCAD ecosystem. Then trace and markup workflows is the cloud or web trace overlay, markup imports that speed iterations and preserve the base drawing while accepting design feedback. It's also driven by AI. Then the specialized toolsets. AI is not there the same way the main AutoCAD has, but it's already surfacing inside the specialized toolsets such as architecture, MEP, mechanical, electrical, plant 3D, map 3D, and raster design. So these toolsets include industry-specific automation, such as the component libraries, rule-based placements, automated isometrics, P&ID to 3D workflows, and GIS integration. Autodesk is increasingly adding AI assistant features into the core workflows that these toolsets rely on, such as the content suggestion, smarter object conversion, and guided tasks, which you get with your Insight. So a practical tip, the specialized toolsets mostly provide domain automation today, but the core AutoCAD AI, so the core AutoCAD, has the smart blocks detection and the assistance. But it benefits all users across the different toolsets and disciplines. Then you also have third-party AI plugins that one could add on to AutoCAD, such as on the screen you can see CAD GPT. It's a chat assistant add-in that generates Lisp or Object-ARX code, helping with commands and provide 24/7 CAD help inside AutoCAD. And then on the Autodesk App Store, once again, you can go search for terms such as AI or assistant or machine learning or PDF detect or automation, or within AutoCAD to discover many small utilities that speed up tasks like batch processing or data extraction or conversion or code generation. So other categories to look for would be PDF to DWG cleanup tools or batch conversion, a raster to vector data, Lisps, macro generators powered by large language models. You have other sort of tools that you can go look for on the Autodesk App Store that help with different tasks, speeding up your workflow. Then we have the voice assistant, so you can speak with voice to AutoCAD. So this voice assistant, you download it from the Autodesk App Store, and then on your cell phone, you also have to do a second part, so you can speak through your cell phone to your computer to draw in AutoCAD. So this mobile application is designed for architects and engineers who uses AutoCAD software. It serves as an assistant that comprehends over 1,000 AutoCAD commands. The app connects to your personal computer via Wi-Fi or Bluetooth, allowing you to voice your commands without the need to navigate the program's interface, without moving the mouse or touching the keyboard. Furthermore, the app offers an extensive library of DWG format blocks spanning 23 categories, such as trees, furniture, symbols, transportations, and more. This collection includes high-quality blocks, including versatile dynamic blocks. So unlock the power of remote block insertion in the AutoCAD environment with the mobile app. Empower yourself with tools for rotation, scaling, mirroring, copying, to revolutionizing your design interaction. Additionally, the app includes a mechanism for memorizing individual commands' pronunciation nuances. Occasionally, the voice recognition engine might be uncertain about the precise command spoken by the user. In such cases, the engine will present the user with multiple suggestions for the best result. Often, one of these options will include the desired command. The engine learns from this, from the choice that you made, ensuring smoother execution in subsequent attempts. So it's machine learning, right? So the more you speak, the more you use, the more it learns. So, enhancing your workflow. Users can also enhance voice recognition efficiency by recording their voice commands or naming them differently using a dedicated tool. The voice recognition engine incorporates these preferences, further personalizing the experience. To start using the application, simply download the small program on your mobile app via the Google Play Store. Additionally, install CAD Assistant for desktop on the computer through your Autodesk App Store. This program is designed to establish a connection between the app and your computer via Wi-Fi or Bluetooth. This is sort of the setup, what it looks like, and how one can incorporate that within your cell phone to computer. And then we have our smart blocks, the B search. So you have the search and convert and detect and convert. It finds all instances of the same geometry in a drawing for efficient block conversion. Text variations. You can convert text variations into block attributes, useful for classifying repetitive but variable types of text. Existing block definitions allows the users to convert matching instances to an existing block with options to adjust the scale and rotation. And then new block creation. Users can convert selected instances to a new block, specifying a block name and insertion point. So this would be an example of how one would go about doing this. So there are two places, on the Home tab or on the Insert tab. On the block panels, so you can say search for geometry that looks similar to, and select what you want. And it will go find all the other places in your model space that has the same or similar geometry. It will tell you it found 4 of them. You can say include existing blocks. There might have been already something that was like that and it was already in a block. Then you can decide at this point, add onto the existing one, find one that is existing and convert it into a block, or you can make a new block, give it a new name, put on a new layer, and new attributes and definitions. You can pick the base point, or it will take the center of the geometry. So I like selecting the base point, saying where I want to have the grip to place it next time. And choose the layer on which you would like it to be. Then all of those individual lines were now converted into blocks unanimously. There you have your grip. You can see on the layers properties, it's on a correct layer as well. And this way you can create your own block libraries and quickly convert the data. And then detect and convert. with the additional option. So improve design efficiency and save time when cleaning up drawings by automatically recognizing the objects to convert into blocks with the help of the Autodesk AI. AutoCAD now includes additional controls to refine and modify the results with the new review toolbar. With the power of AI, AutoCAD now does the heavy lifting, finding repeated geometry and turning it into efficient, editable blocks. It's a huge time saver and a big win for cleaner, smarter drawings. If you haven't tried this feature yet, I highly recommend jumping into the AutoCAD 2026 and giving it a go. And if you want to explore more, check out the official help guide. So when you open that, you just press F1 and it opens the help guide where there are some more videos and things that will assist you in using this. So here, for example, I can go look for all the blocks, detect them, find them, and then it will go look throughout the entire drawing, the entire model space, for all of them that are the same, based on the one that I selected. There are 28 of them. Then you can decide whether or not you want to make an edit to that block, and it will update all of them. Or you want to maybe explode them, you want to swap them out, put them on a different layer, those kind of things. So what I'm doing here is I'm just selecting my I-beam, and I am going to go and change it to be something completely different. So just to be dramatic, let's change it to a bath. So I will swap out all my I-beams for a bath just to make it obvious. Then determine on which layer it must be. So I'll make it a pink color so it's easily recognized. Then once you do that, it will ask you just to make sure, is it the way you want it? Do you want to rotate it perhaps? Do you want to move it? Do you want to scale it? Do you want to make any adjustments to it? You can make the adjustments as you need. And then if you are happy and you want it to be replaced, you can say OK, and it will replace all of the I-beams with a bath. So first you converted all of the I-beams, which were just lines and polylines, into a block, and then you selected all of them and swap them out for the correct size or correct block type throughout your entire model space, instead of going to look for them one at a time. And you also now know that you selected all of them. So AI in AutoCAD continued. So we had the AI assistant, we have my insights, and then this is a snippet from the Autodesk AI help page. Since 2009, Autodesk's Industrial Research Lab has published over 65 peer-reviewed research papers, making the Autodesk Research AI Lab the world's leading publisher of original AI research for CAD geometry. Over the last 10 years, Autodesk has invested in artificial intelligence because we recognize the transformative power of AI for the industries they serve. It's already helping customers achieve more with less. Today, Autodesk AI powers workflows and capabilities across Autodesk software and the Autodesk platform, with more capabilities coming in the future. On the right hand side, that is the AI Autodesk Assistant. So at the very far right within your Autodesk or Autodesk toolset applications, you will see this little bubble, which I highlighted in green on the screen. And there you can talk to the AI assistant and ask for help or suggestions. So how do I use the polygon tool? And then you will get either a step-by-step guide or a video, a link towards a video to see how the tool works. You can do this for all the different tools and functions within AutoCAD. It's a nice way to learn the software and enhance your understanding of the software. So how it helps you is it makes you more productive by uncovering features you didn't even know existed. Promotes continuous improvement, even for seasoned AutoCAD users. Act like a smart mentor in the background, nudging you with practical, actionable tips, not just generic suggestions. It reduces learning curves for new tools or updates rolled out in the latest versions. Okay. Oh, apologies. Went too fast there. So AI in AutoCAD, last part, trace and markup. So the trace and markup is also enhanced with AI. So what is it? Trace is a collaborative feature in AutoCAD that lets users add feedback and markups to a drawing without altering the original. It acts like a digital overlay, transparency paper over. Think of it as virtual tracing paper, where collaborators can review, comment, and sketch directly over the design. Markup Assist is an AI-powered tool that detects and interprets hand-drawn or imported markups, PDFs or scanned sketches or photos in JPEG or PNG format, and automatically converting the scanned text into AutoCAD geometry, AutoCAD text, or AutoCAD commands. So why use it? Keep the source DWG file clean while allowing iterative feedback. It enhances remote collaboration with project stakeholders, especially on shared designs. Simplifies the revision management. No more red pens on paper or back and forth email notes. I see we've reached 1 hour. Okay, so basically it looks like this. I imported a PDF, and then you can convert your data, your hand-drawn information into actual usable geometry within AutoCAD, and it's assisted with AI to recognize the text and information. So one would use Autodesk Forma for your AI power design, for environmental analysis in early stage, solar, daylight, wind, and embodied carbon insights. Then for optimization for comfort and energy use of the buildings, and then informed decisions making before your BIM development. Then AI is at the core of all the analysis and simulations within Forma. It has intelligent 3D modeling and sketch mode options, the AI rendering for photorealistic visuals, as I showed with the Veras tool. Then you have smart collaboration using the Autodesk Construction Cloud and Docs. And then you have a lot of extensions and plugins that all uses AI for advanced insights. And this can be used from concept to BIM. So you would have your Forma start into Revit, Revit to AutoCAD, and Civil 3D, Navisworks, and then all of this lives together on the Autodesk Construction Cloud using your BIM Collaborate Pro. And it has the end-to-end intelligence from the sketch to the construction. So it keeps the entire ecosystem connected using AI, all the way from the concept to the construction. And then sustainable design in action. It's one subscription, the AEC collection. It's one ecosystem. All of them are interconnected. They also have interoperability tools with each other. They're all connected in the cloud, and it has countless possibilities. Any kind of structure can be done. We're doing a bridge, a kiosk, a house, or a yacht. Revit would be for the models smarter, design better, and document efficiently. Forma is for analyzing the environment. Insight for real-time energy and performance simulations. Civil 3D for the site and infrastructure design with precision. BIM Collaborate Pro would be for issue tracking, clash detection, and more. And then Docs is where all the documents live in the cloud for every team member to gain access to and work on the same model at the same time. So key takeaways would be AI enhances the creativity, accuracy, and efficiency. Sustainability starts with data-driven design. Forma, Revit, and AutoCAD form a connected ecosystem. Autodesk Construction Cloud unites every stage, and then smarter workflows lead to greener outcomes. So thank you for listening to this long webinar. I hope you did find this informative. But as we wrap up, it's clear that the future of architecture, engineering, and construction is one where AI is an active partner, helping us think bigger, design smarter, and build more responsibly. Autodesk vision is to create a connected ecosystem where every decision is informed, every workflow is optimized, and every outcome is sustainable. AI doesn't replace creativity. It amplifies it. It allows us to focus on what truly matters, designing the space to improve the lives and respect of the people and the planet. So yeah, thank you for joining the session on AI-powered design and sustainability in the AEC collection, and for being part of this movement shaping the future of intelligent design. If you have any questions, please do not hesitate to contact us here at Micrographics. I hope you did find some information valuable. If you haven't subscribed, please do so, and don't forget to like and hit that notification bell for future webinars. Thank you again, and goodbye.